In this skill, we're going to calculate the coordinates of the center of mass of a system of objects. This first question has a system of 2 objects distributed as shown in the image provided. We can see we've got this graph with 0, 0 marked here, and each square is 1 centimeter. We have these 2 objects here. Object A, which is larger, we're told it's 8 kilograms, and object B, which is smaller, we're told it's 5 kilograms. We need to figure out where the center of mass is going to be. Before we do that, let's just make a prediction so that we can check if our answer is correct at the end. So we know that the center of mass is going to be somewhere in between objects A and B, but since object A has a bigger mass, we're going to expect it to be closer to object A than object B. So I'd be guessing our center of mass would be somewhere around here. Now let's go ahead and do our calculations, and then we can double check those using this guess to make sure it makes sense. So to do that, we're going to be using this equation from our reference sheet for the center of mass. The location of the center of mass, that's the R, is equal to the mass times the location of each object added together divided by the total mass. The ... means we could add more and more masses depending on how many parts our object is made up of. In this question, our object is only made up of 2 parts, so we're going to use the formula. The location of the center of mass is equal to mass of object 1, I'm going to call it A because we've got object A and B, multiplied by the location of object A, plus our second object, mass of B, multiplied by the location of object B. We don't have any more objects, so I'm ending that part there, divided by the total mass, which will be the mass of object A plus the mass of object B. So that's my formula, and I can use that in both the X and the Y directions separately to figure out the coordinates of my center of mass. So first let's look at object A. I'm going to fill out the table as I go to help keep track of my numbers. So object A, we can see from the graph here, has a mass of 8 kilograms. Object B, we can see from the graph, has a mass of 5 kilograms. And I'm going to add those together to get the total mass of the system. 8 plus 5 gets me 13. Next, I'm going to look at the X coordinates, which is horizontally. We know that this point is 0, and each square is 1 centimeter. So that means that A is at 2 squares in, so that's going to be 2 centimeters in the X direction. And B is, let's count, 1, 2, 3, 4, 5, 6, 7, 8 squares in. So B is at 8 centimeters in the X direction. So our X coordinates of object A is 2 centimeters, of object B is 8 centimeters. Now we want to figure out the X coordinate of the center of mass. So we're going to plug all that into this equation here. So the location of our center of mass in the X direction is going to be mass of A, which from our table is 8, multiplied by location of A, which from our table is 2, plus mass of B, which from our table is 5, multiplied by location of B, which from our table is 8, divided by mass of A, which is 8, plus mass of B, which is 5. Putting that into our calculator gets us a center of mass for our X coordinate of 4.31. So looking at our graph here, that location that I marked on should be around 4.31 centimeters. And looking here, it's 1, 2, 3, 4 and a bit squares in. So that matches up with my prediction that I made earlier. So I'm pretty confident on that one. I'm going to enter my number in here. And that's correct. Awesome. Now our next step is finding the Y coordinate. Both A and B lie on the x-axis, so they both have a y-coordinate of 0 centimeters. So If both of them have a coordinate of 0, that means my system is going to have a center of mass that also has a coordinate of 0. So we don't need to put those numbers into our calculation because it's obviously just going to be 0. It's going to be on that same line. Awesome, so we found our coordinates of the center of mass. The x goes first, which is 4.31, and then the y, which was 0. Let's do one more question of this type. In this question, we have a 2D object, which we can see here, and it's been split up into 3 parts. We've got part A here, part B here, and part C here. We're told the object has a uniform density of 1 kilogram per centimeter squared. So since one square has 1 centimeter height and 1 centimeter width, that means one square is going to be 1 centimeter squared in area. So that means for every square, it's going to be a mass of 1 kilogram. So that's how we'll figure out the mass of our shapes. So first, we're going to go through each shape and figure out its mass, and we're going to figure out the x and y coordinate of that shape. Then we'll do our calculations. So for object A, it's made up of 2 squares, so it's going to have a mass of 2 kilograms. For the center of mass, it's going to be in the middle of that shape because it's a symmetrical shape. So the center of mass is going to be along these lines. It's going to be in the middle there. So that makes it halfway along the first square in the x direction. So an x coordinate of 0.5. And in the y direction, it's 1, 2, 3, 4, 5 squares up from 0. So those are the coordinates of shape A. For shape B, it's made up of 4 squares, so it's going to have a mass of 4 kilograms. For the center of mass, again, it's going to lay along the lines of symmetry since it's a symmetrical object. So it's going to be there. So in the x direction, that's 1, 2.5 squares in from the left-hand side. So that's 2.5 for our x coordinate. And in the y direction, we're 1, 2, 3, 4, 5, 6 squares up. So our y coordinate is going to be 6. Finally, for part C, that is made up of 12 squares, so it's going to have a mass of 12 kilograms. For the coordinates of the center of mass, again, we're looking for the lines of symmetry to see our center point is here. So in the x direction, that's 1.5 squares in. So we've got an x coordinate of 1.5 centimeters. And in the y direction, it's 1, 2 squares up. So our y coordinate is going to be 2 centimeters. So now we need to use those in our calculation to figure out the x and y coordinates of the center of mass. However, right now our equation's only set up for 2 parts, A and B. We also have a part C, so we're going to add that into our equation now. So we're adding mass of C times the location of C on the top, and on the bottom we're adding the mass of C. So first let's go ahead and do our calculation for our x direction center of mass, our x coordinate. So it's going to be the mass of object A, which is 2, multiplied by the x coordinate of object A, which is 0.5, plus the mass of object B, which is 4, multiplied by the x coordinate of object B, which is 2.5, plus the mass of object C, which is 12, multiplied by the x coordinate of object C, which is 1.5. Then we're going to divide that by the masses of our 3 objects added together, which is 2 plus 4 plus 12. 2 plus 4 plus 12 gets us a total mass of 18 kilograms. So putting that all into our calculator is going to get me a value for my center of mass in the x direction of 1.61 centimeters. Before we check that, let's just look at our object and make sure that makes sense. We've got object C, which has a center of mass along this line, And then we've got object A with a center of mass along this line and object B with a center of mass along this line. So if object C's center of mass was to be slap in the middle of object C at 1.5, we then have object A to the left of that line and object B to the right of that line. But object B is bigger than object A. So that means that the center of mass is going to be shifted slightly to the right of 1.5, which probably gets us a number around 1.61. So that makes sense logically based on the way our shape looks. Let's go ahead and enter in that answer. Awesome, we've got our x coordinate. Now let's do the same for our y. So I'm going to do the same calculation for the location of our y center of mass. So I've got the mass of object A, which is 2, multiplied by the location of object A. Our y coordinate for object A is 5. Plus my mass of object B, which is 4, multiplied by my y coordinate of object B, which is 6, plus my mass of object C, which is 12, multiplied by my y coordinate of object C, which is 2, divided by the total mass of all my objects, 2 plus 4 plus 12, which is 18. Putting that all into my calculator gets me out a y coordinate for the center of mass of 3.22. Again, before we check that, let's make sure that makes sense. If we just have object C, our center of mass would be along this line at a y coordinate of 2. However, we also have objects A and B, which are going to shift that center of mass up. So it's going to be more than 2, but not a ton more. So 3.22 centimeters makes sense. That puts our center of mass somewhere along this line here, which makes sense because A and B are fairly large, but C is the biggest object there. It's bigger than A and B combined. So it makes sense that the center of mass is somewhere between 2 and 4. Let's enter that answer and check that that's correct. Awesome. So we've got our y coordinate center of mass as well. So overall, that puts our center of mass at an x position of 1.61, which is round about here. And a y position of 3.22, which is round about here. So that position I've marked with an x is the location of our center of mass. Let's go ahead and fill in, finally, the coordinates of our center of mass of the object. The x coordinate is 1.61 and the y coordinate is 3.22. So when using this equation, your first step is to figure out for each of your objects what are their masses, what are their x coordinates, and what are their y coordinates. Then you're going to apply this equation separately for the x and the y coordinates to figure out your x and your y coordinates separately. Remember that the number of things in our equation is going to be the same as the number of objects. So if we just have 2 objects, there's going to be 2 items on top and 2 on the bottom of our equation. If you've got 4 objects, there's going to be 4 on top and 4 on the bottom.